This is the third lecture for week 4. We are actually going to revisit the conditionals again. There is something that we did not discuss in the previous week. So let's have a recap of what we already know. So we know that if we just want to have a detour in our sequential execution, we can define an if condition. Whenever this if condition is true, we can define a set of statements, a block of statements which will be executed when this particular condition is true. And if the condition is false, the block is simply ignored. This is what happens with an if condition. We can also add an else, by the way, to this. We can match this if with an else. So in this case, the detour will always be taken. It will either go here, when the condition is true, or it will go into the else part when the condition is false. So this we already know. And we also knew that we can actually create ladders of if and else, something like this, that you basically have if, then an else if, there can be a number of else ifs here, and then finally an else. So this is a very simple example. We are basically saying that you are going to enter the year in which you are currently studying, and this is basically applicable to you guys right now, that if the year is 1, it will simply show you that your semester is currently being delayed. But for the second and third and fourth year guys, it will just simply show that the semester is on time. If you enter any other value for year, because these are the only 4 valid values, if you enter anything else, it will simply print nice joke. So this is a very simple example of where we use else if. But what is different with this particular example is that here the condition is based on one single variable, and that is year. Okay, so you can see that when year is 1, I'm doing something. When year is 2, 3, or 4, I'm doing something else. And otherwise I simply, for any other value, I'm simply printing something else. So these are the 3 different scenarios I have to cover. Now, if you are having a condition like this, if you have a logic that can actually be based on one single variable, there is another construct in programming that you can use, and this is the switch case construct, okay, or switch in the short. This is the syntax. You start by basically putting that particular variable inside a switch statement. So basically, we just say that we are going to switch this variable, and in the case of our academic informer example, this variable will be year. Then you define a number of cases, okay, and each of these case actually corresponds to one particular value of this variable that is relevant for us. Okay, so this is the idea, that a particular variable usually can take a lot of values, but only a small set of values will be relevant for us. So here what we are going to do is, in this particular example of academic informer, we have 4 values that are relevant: 1, 2, 3, and 4. So the 4 years, any other value is basically not relevant for us. So but anyhow, what we do is, for each relevant value, we define one or more statements, zero or more, actually it is not one, but basically some statements that I want to execute if this particular case of the variable has matched. So when I say a particular case has matched, it means that this particular variable v has this particular value, right? So this case a, case b, case c, case d, what you see here are, in the example of academic year informer, these will be case 1, case 2, case 3, and case 4. So these are the 4 values for the variable year, and for each case we can define 0 or more statements to be executed in case the variable has that particular value. We can also define, this is an optional thing, it is not necessary, but we can also define a default case. So a default case is basically when all the defined cases that you have put in the code, they are not matched, right? So for example, if the user enters the value of year which is not 1, 2, 3, or 4, so this is the case of default. So now you can see that we have this kind of a structure, that instead of just a block for if, a block for else, we basically now have one block each. By the way, these blocks can also be empty, but for the case of a general understanding, so essentially there is an associated block now for each case. Okay, and The overall idea is that for one particular value, I would like one of these blocks to be executed based on whichever is the value. And by the way, this is not only applicable to C. This switch case construct is available in many programming languages, C++, Java, at least that I can tell you, because the syntax in C++ and Java is exactly the same as in C, maybe with some minor changes. For example, in Java, I think we can also, in the later versions of Java, you can use strings instead of integers. But in C, basically the type of variable over which switch will work are integers. Okay, integers are something that can implicitly be converted to integers. I'll leave something related to that in the homework. So you can use any such variables, but the overall idea is that what I want is, for a particular value of this integer, I want a particular set of statements to be executed. So this is where I use switch case. There is, however, a major problem with this so-called switch case constructs, uh, because they might seem similar to the else if thing clauses that we were writing, where I say, else if this is true, do this, else if this is true, do this. They are not really the same, right? Because the order in which you define these cases actually matter. Why? Because once a particular case matches, okay, so essentially we start looking at the cases from the top, and whichever case matches, okay, the statements for that case, as well as all the cases that are defined below it, right, they are all executed. So it's like the control simply falls through from that particular point. Whatever statements are written inside your switch construct, irrespective of what case it is, they are basically executed in that particular order. So it's as if, we say that it's as if the control has fallen through from that particular point. It will keep on executing everything that is defined below. So this is why the order is important. So this is the example that I'm trying to tell you, that let us say you have defined your cases in this particular order: A, B, C, D, and then the default. And let us say the variable's value is currently A. So now all these blocks, because this is the block that gets matched, this is the case that get matched, so the block for this case as well as all the blocks defined after that are executed. Similarly, if the variable's value is C, A and B will not be executed because they are defined before C, but C as well as all the cases defined after that, the blocks for them will be executed. So now you can understand that there is a problem. What I really wanted was, I wanted a set of statements to be executed only when a particular case was true, but that is not happening here. As soon as a particular case is true, everything defined after that, it gets executed. So usually what we do is, uh, yeah, so basically, usually what we do is, yeah, this is not true. I mean, even default, so default will also be executed. I'll just remove this from the slide. Default 2 will be executed. So this is what will happen, but that what we try to do is, we add a break statement. Okay, this is the statement that I was talking about in the previous lecture as well, that what if I want to provide certain conditions in the middle of a loop. I'll need some mechanism. So this is that mechanism. This is the break mechanism. So what happens is something like this. You define your cases like it, and then you add a break statement after the set of statements. Okay, by the way, these set of statements do not need a braces, and you can understand why, because even though it looks like they are different code blocks, essentially they are the same block only. Okay, it's just that once you start executing from one point, you simply keep on falling through. So even though logically they are code blocks, but when they get implemented, they are not really different code blocks. They are basically the part of the same code block. And if I want to exit from a code block prematurely, I need something like this, a break statement. So this is how we usually write switch cases. For each case, we'll supply a set of statements, and then we write a break after it. Okay, so this means that whenever, for example, if now case B is matched, these statements will be executed, and before you go to these statements, you'll have a break. So this means that just go outside the switch case. This is what break will do. And usually you don't need, usually we actually put default at the end of the switch case, and that is why we don't need a break. So don't get confused. Okay, that I will rectify in the slides. Even the default block will be executed. It's just that usually what we do is we put it at the bottom, and we don't put a break here. Okay, it's just that there is no point putting a break here, because the control will anyhow go just outside this, right? So but you can put a break here. And by the way, uh, so this is what I'm trying to say, that if there is no value which gets matched, default will be matched. Okay, but there is something that you should understand, and this is a very common confusion. We usually define default at the end, but it is not necessary that you do it like this. Okay, you can, for example, define default anywhere here. Okay, so in that case you will need a break statement, because the default is nothing more than just yet another case. Okay, and as I told you, these blocks are not really different blocks, they are basically the part of the same blocks. So if you want to jump out of any particular point, you'll need a break statement. So keep this in mind. Usually we define default at the end, and that is why I don't need break. But if you, for some reason, are defining default at some other place in this order, and that is why order is very important. So if you are defining default at any other point here, you will need a break statement with the default as well. So what exactly is this break statement? So we realize that it is going to take me out of the switch case, right? So if I issue a break, whatever statements were executed, nothing before, nothing after that in the switch will be executed. This I understood, but it is not just for switch. This is also applicable to loops, for example, and that is what I was saying, that this is not just for switch, and we can use it in loops as well. I'll come back to it. Just let us, this is the same program that we wrote using the else if things, but now I have used a switch case. So this is a very simple example. Basically, I have four values, 1, 2, 3, and 4, and for each value I wanted something else to be done. For example, for case 1 I wanted to print this, for 2, 3, and 4 I wanted to print this, and default, and as you can see, because I have defined default at the end, I don't need a break here. So in the case of default, if the user enters any other value than 1, 2, 3, 4, I simply print nice joke. So it is equivalent to that if else if thing that we saw at the beginning. Now now there is, by the way, something that you need to understand, that that drawback of switch case, right, where I said that if I do not put a break here, if case 1 is true, 2, 3, and 4 will, as well as default, will be executed, right? This is what I told you, that they are not really different blocks. They are essentially, they are just like labels. Okay, so if any of these, if the execution starts at any of this point, it will simply fall through, including the default. But now you can see that why it, even this so-called drawback, can actually be beneficial for you, right? So why? Because whatever we are doing for case 2, 3, and 4 is basically a repetition, right? I wanted to issue the same statement when it was 2, 3, and 4, but here I'm writing it explicitly for everything. So this is where a nice hack can be used. What you can do is you can write it something like this, right? And that is why I told you that the block of statements for each case, they can be empty as well. Okay, so this is what I have done here, that I have used empty blocks for case 2 and case 3, and I'm basically chaining them, right? So I'm taking advantage of that fall through, that now what happens is, whether case 2 is true, case 3 is true, it will simply fall down, it will come up to case 4, it will execute this, and then it will break out, right? So this is a very common hack to use switch cases. So if you have a cluster of values for which you want to do the same processing, you simply put one after the other, you put those cases one after the other, and then only in the last of the cases you define your statements, and then you put a break. So this is a smart hack to use switch whenever you have multiple values for which you want to do the same processing. uh, so anyhow, now let's just have, come back to the break statement, because break is more than just getting out of the switch. It can actually take you out from the innermost. So innermost is an important point here, that it can actually take you out from the innermost switch or loop. Okay, so it could be a switch case or a loop construct. So basically, let us say if you have if you have a particular scenario where you have a switch inside a loop, or a loop inside a switch, or you have nested loops or switches. Okay, so this is the point. I have not told you what nesting is, but basically if you have one construct in another, I'll just talk to you what nesting is. The idea is that the break will only take you out from the innermost one. Okay, not from the outermost, not from the outer loops or outer switches. So let me give you a simple example of what so called nesting is, so that you can understand. So nesting essentially means that you are going to use a particular construct inside another construct, right? So this is not just applicable to loops or switches. We can also have, for example, nested ifs. So essentially within an if construct, I have another if construct. So this is kind of nesting. They are the same constructs. And nesting is a very common term that is used in programming. We'll once you start studying object oriented programming, you will also hear terms like nested classes. So this is a very simple but a very common example in programming, where we use the same construct within the same construct, something like this. So if within if is kind of nested if. A switch within a switch is a kind of a nested switch, and a loop within a loop is kind of a nested loop. So this is, just to give you an example, that if you use a break here, it will not take you out of this loop, right? Or a break here will not take you out of this switch. A break here, sorry, break is not applicable to if. So basically, this is what I was trying to tell you, that a break is only applicable to the innermost block. Wherever you issue it, break will simply take the control out of that block. It will not take you out of the exterior blocks or the outer blocks. Okay? And by the way, the loop, when I say nested loop, it doesn't mean that it has to be the same loop, right? So for example, either one of these could be while or do while. So the idea is that loop inside a loop is a kind of a nested loop. Anyhow, so break can be used to put loop terminating conditions as well. So now you can see that because it can take you out of the of it can take the control out of a loop. You can use that idea to actually put these so-called loop terminating conditions in the body of the loop as well. So we saw that in while you put the conditions at the top, in do while we were putting the conditions at the bottom, and in for we were for is similar to while. It's just that it has some more compact way of defining other stuff as well. But the idea was that when we write a typical loop, we either define the condition at the top or at the bottom, but not inside the loop of the body. But now with the help of the break statement, you can actually define these conditions even within the loop of the body. So this is the same factorial program. We've probably overdone it by now anyhow, but like this is one more way of calculating factorial. Now here what I'm doing is I have not given really a condition to terminate this loop. So while one basically makes this loop a infinite loop, but what I'm doing here is I'm using a condition, an if condition with a break. So now and this is within the body, between the body of the loop. So essentially what will happen is whenever num becomes greater than or equal to 0, the control will get out of this loop, right? So this is the idea, that with the help of break, we can define conditions within the loop body as well. And this is a very common way to use break as well, right? So we often use break to get out of loops. Now, because we are studying break, we should also have a look at what is so called the continue statement. So break statement, what it does, it actually takes you out of the innermost loop or switch. Continue statement will basically start the within, and this has to be innermost as well. I have not written it here. So that is also applicable to the innermost loop. Continue is applicable only to the loops and not to the switch cases. But what it will basically do is it will begin the next iteration of the loop immediately, right? So you can assume that if while executing a loop, if continue statement is encountered, you simply move to the closing braces of closing bracket of your loop. So just assume that as if continue was the last statement of the body. So your yeah, your if for example you are you're going to check the loop condition after this, then the condition is checked and then the loop starts again. So the idea is continue simply tries to emulate as if the body of the loop has finished and now I need to restart everything. So it is not really used as often as break. You'll see why, because most of the time it is not really required. The loop will anyhow restart in the next iteration. Sometimes you would probably want the loop to start, the next iteration to start prematurely. That is when you use continue. And this I have already told you that this is only applicable to a loop. It is not applicable to a switch. And yeah, this is a kind of pitfall. A lot of people don't understand this, that but if you write a continue statement within a switch, okay, and let us say this switch is inside a loop, uh, issuing the continue statement will actually restart the loop. Okay, it restart as in the restart the next iteration of the loop and not the switch part, because as I said, switch is not something that is affected by continue. So this is the very forced example, I would say, in the same factorial program. Now I have removed that break statement. I have inverted the condition from num greater than equal to 0 to num less than 0, and I simply say continue, right? It's, as I said, it's kind of a forced example. We usually do not require continue in most cases. There might be very specific cases where you require it, but I really could not think of any case where I could show it in a better fashion to you. So I just decided to overuse the factorial program once again. So this is the homework. We are going to discuss this on the in the Wednesday class. Okay, so just have a look at it before that. Thank you.